Hi, in this video we are going to do the numericals of chapter 4. So before we go to the numerical, let's have a look at the formulas. So formula number 1, torque is a product of force into the perpendicular distance. But the perpendicular distance is between which two points? So the point where the axis acts, so this is the axis, and the force is applied. So the perpendicular distance between these 2 points is what we are talking about over here, and the magnitude of the force applied. Second thing is the laws of moments. So laws of moments tell us that if there is a scale and it is pivoted at the center, if there are weights acting on two sides, so let's call this weight as W1, W2, and the distance of these weights is D1 and D2. So these weights are going to cause what is called as anti-clockwise torque. And if there are weights on the other side, which are at a distance of W3, and there is D4. So these weights are going to cause what is called as a clockwise moment. Now, if the scale is balanced, that means the total of the anti-clockwise moment is equal to the total of clockwise moment. So how do you write that? So W1 times D1 plus W2 times D2 is W3 times D3 plus W4 times D4. Okay, so always the clockwise and anti-clockwise, if it is equal, then the scale is balanced. If they are not equal, then the scale will not be balanced. So whichever is greater, for example, if this is 200 Newton meter and if this is 150 Newton meter, then the net torque will be 50 Newton meter anti-clockwise. Okay, and the third type, not a type, the third important part that is there, if the scale is uniform, then the weight of the scale will act at its geometric center. And if the scale is not uniform, that means the weight will act at a point other than the center. So these are some of the formulas. And based on these formulas, there are some questions that we are going to do in this review. So let's have a look at the first question. In this, a wheel is given of diameter 2 meters. And at this particular point, you can see a force of 2 Newton is acting. So they are asking what will be the moment of the force about the center point O. You can pause the video, try to solve the question, and then see how it has been solved. Okay, so this is the axis of rotation. This is the point where the force is applied. So therefore, this will be the perpendicular distance. Now, since the diameter is given as 2 meters, therefore the perpendicular distance, that is OB, will be equal to 1 meter. And torque, which is a product of force into the perpendicular distance, it will be 2 Newton into 1 meter, that is equal to 2 Newton meter. One thing we need to understand that the arrow mark indicate the direction in which it is going to turn. So therefore, this is going to be clockwise. When there is a diagram and the diagram shows the direction of force, and if you are able to understand that with that force, if it is going to move clockwise or anti-clockwise, that should be a part of your answer. Otherwise, that answer will be incomplete. So the answer to the question, moment of force, the moment of force about point O will be 2 Newton meter. Now, in this question, if they had asked what will be the torque about point A, then this will be the perpendicular distance and the whole body would have turned again clockwise, but the only difference will be F into the perpendicular distance, and that time it will be 2. And so that will be 4 Newton meter clockwise along the axis at A. Okay, fine. Let's go to the next question. Okay, you can pause the video, try to solve this question, and then have a look at the solution. Okay, so in this question, they have said that all these forces are 4 Newton each. And from the axis, that is point O, the perpendicular distance is provided to you. So this is the perpendicular distance, this is the perpendicular distance, and so is this. So they ask for what is the least moment of force about O. Now, since moment of force is a product of force into the perpendicular distance, since force is same, so we have to look for the least distance to calculate the least moment. And the least distance over here is 0.6. So therefore, the which force has the least moment? And the answer is C. Okay, C has the least moment. Which force is the greatest? Again, going by the same logic, it will be force into the perpendicular distance. Since the force is same, we will look at the longest distance, that is 9 meters. And that answer is A. force A will cause the greatest torque. Now name the force producing clockwise moment. Now clockwise, we will look at a turning that way. So here you have A, which is clockwise, B also. So the answer is A and B. But if you look at force C, that is turning it anti-clockwise. So anti-clockwise is force C. Okay. They asked for the resultant force about point 2. What will be the resultant torque about point 2? So this should be resultant torque. Okay. So here we have the torque that is caused by A is 4 into 0.9. Torque that is caused by B is 4 into 0.8. So this will give me 3.6 Newton meter. This will give me 3.2 Newton meter. Now both of them are clockwise, so we will add them. So that will be 6.8 Newton meter clockwise. Now the torque that is due to C is 4 into 0.6. That will be 2.4 Newton meter, and this is anti-clockwise. Okay. Now we want the resultant, so let me call it as the net torque, and the net torque will be 6.8 minus 2.4. That will be 4.4 Newton meter. Now we will take the sign of the greater one, and that is clockwise. So the answer will be 4.4 Newton meter clockwise will be the resultant torque or the net torque acting about 0.4. Okay, so this was the second question. Let's move to the next one. In this question, be careful about these words: uniform meter scale. Okay, so if I have a scale which is a meter scale, so this is 0 and this is 100 centimeter, and this is a uniform scale. That means if there is a 50 centimeter mark, the weight of the scale will act at this point. Okay, now there is a knife edge placed at 55, so this is 55, so therefore obviously the scale will not be balanced and the scale is going to topple that way. Now to prevent it from toppling, we have got a 25-gram mass, and that has to be suspended at one end. A scale has two ends, 1 and 2. So which end? Now since the scale is dropping this way, so we have to attach a weight on the other side, so that to prevent it from falling. Okay, another way to come to that conclusion is the weight of the scale is acting here. So to counter this, we need a weight on the other side. Another way to come to that conclusion is this is the longer part of the scale and this is the shorter part of the scale. So to balance the scale, one has to add the additional weight on the shorter part, and that additional weight is 25 gram force. Okay, so draw the diagram. That's what we have done. Now calculate the mass of the scale. So here we need to write that since the scale is balanced, the sum of clockwise moment is equal to sum of anti-clockwise moment. Okay, so this is a conclusion that because the scale is balanced, then we can say that the clockwise moment and anti-clockwise moment are equal. So this is the clockwise moment, so that is 25 multiplied by perpendicular distance. So this distance is 100 minus 55, and that will be 45. And on the other side, the one which is causing anti-clockwise is the weight of the scale times the distance. So always the distance has to be taken from the point where the weight is acting till the point where the fulcrum is. So in this particular case, this is 5. So therefore we get weight is 25 into 45 upon 5. 5 ones are 5 nines are. So this will be 225 gram force. So that will be the weight of the scale. So they are asking for the mass, and remember, mass will not be in gram force. So your answer will be mass of scale is 225 grams. Okay, if they ask for weight of the scale, we will write 225 gram force. Okay, let's move to the next question. A uniform meter rule weighing 10 gram force is pivoted at 0 mark. Okay, again, we go by what we have discussed earlier. So this is 0, this is 100 centimeter. Because this is a uniform meter scale, the weight of the scale will act at 50. So this is 50 centimeter, and that's where the weight is acting. Now the scale is pivoted at 0 centimeter mark. Okay, so obviously the scale will fall this way because the weight of the scale is going to bring it down. So they are asking what moment of force depresses the rule. So moment of force is product of force into the perpendicular distance. We know that the force is the weight of the scale, which is given to be 10-gram force, okay, multiplied by perpendicular distance from the point where the fulcrum is and where the weight is acting. So therefore this distance is 50 centimeters. So therefore this is 500 gram force centimeter, and it is clockwise, okay, because it is going to turn the scale in the clockwise direction. Fine. Okay, what is the second point? How will you make it horizontal? By applying the least force. So one thing is there that if something is making the scale go down, you need to apply force upward so that you bring it back to the horizontal point. Okay, and the next important part is it has to be least. Now you know that torque is equal to force into perpendicular distance. If you want force to be the least, that means your distance has to be maximum. So from the fulcrum, you have to apply the force at the maximum distance. So this is my fulcrum and this is the other end. So obviously I will apply force here to make the force the least force. And what that torque has to do, the torque has to be equal to 500 gram force centimeter, because that is what is making the scale down. So therefore F multiplied by 100 is 500. So F is 5 gram force. Okay, so this is the answer to the question, how can I make it horizontal? By applying the least force. Okay, so therefore the answer is 5 gram force is applied at 100 centimeter mark in the upward direction. Okay, so we are specifying that we are applying the force in the upward direction because that's going to counter that 500 gram force centimeter torque, which was depressing the rule in the first part.